Hello everyone, this is Pranava Rao. In today's video, we'll be going through one of the old challenges of MetaCTF under the category of cryptography. So this is a quite simple cryptographic example of XOR algorithm. Okay, so let's dive into it. So the challenge says, I generated some art as a PNG image, then encrypted the file using 8-character long key that was repeated. I can't remember what it was. Can you help me decrypt the image and retrieve the flag? So the challenge says that there is some art. Let's open that art in the new tab. Okay, we need to download it to save. As a PNG, it's a PNG image which is encrypted using the 8-character long key. Okay, so let's open the image and look into it. Downloads, and this is our encrypted image. Let me try opening it directly. uh, Encrypted dot. Okay, there's no application which is opening it. Okay, so basically this image is encrypted. It's a PNG file format, and it's encrypted using an 8-character long key which was repeated again and again in a sequence. So I'm guessing it could be an XOR encryption algorithm which was used for encrypting this particular file. Okay, so for getting this file retrieved to the original file, we can use a tool called CyberChef. Okay, so CyberChef is a tool which we use for encoding and decoding or encrypting or decrypting different text files and formats using many of the search operators or the operators for doing it. Okay, now I'll upload my encrypted file into the input section here. So we see that this has some total random characters in it. I could even use strings to see if there's any readable key, which I potentially can be using it as my key the for decrypting this particular file. But here I don't see anything as such except that this character is being repeated again and again. Right? There is no particular string as such, which there could be any 8-character long string. Uh, those 8-character long, right? Yep. Okay, so let me even set the minimum length to be 8. I still don't see any useful or something as a key format in it. Now, since I've solved this challenge, this is basically an XOR encryption algorithm which was used for encrypting this particular file. Because when you read this sentence which says 8-character long key that was repeated, it's usually an XOR algorithm where a particular key is repeated over and over and over again in a file. Okay, for example, we could go to our whiteboard. Okay, in this whiteboard, uh, basically XOR works in a principle where imagine I have a password, which I'll read font of this. Okay, so imagine I have a password. Let's take an example in the binary format. Imagine this 11001100101 is my password in the binary format. When I XOR this particular password or repeat this password, it could be n number long. I'm just taking an example with a particular sequence or a key which is only known to me. I get an encrypted file which I'm going to denote it by the letter en. Okay, now the key is going to be repeating itself in the password over and over and over again, which is going to make it encrypted or in a format where it's only decryptable, or we can get the password back from the encrypted file only if we know the key. The reverse process is going to be knowing the key, which is again going to be XORed with the same algorithm, is going to retrieve my password. So the logic of XOR working is basically, let me take an example again. Let me consider this to my, okay, so this is my password. I will write in blue text as my password, and my key is going to be uh, another character. I'll use different bits of binary to it. This could be any character. It does not matter to us. Okay, a straight line. So while going through the process of XOR, it's going to be 1 and 0 is going to be denoted as 1, 1, 0, 0. This is 0, 0, 1, 1, 0, 0, 1. So this is going to be our encrypted key. What we get after XORing, or after passing the password through an algorithm using a key, we are going to be getting this encrypted key. So by going the logic of XOR, if we have any of the two variables with us, we can get back the third variable. For example, if I have the original password with me, and then if I XOR that password with the encrypted file which I have, I can get back a portion of my key. I can get back the portion of my key, right? So because for example, you can use this exact binaries to get back our key, the original key of it. So if you have any of the two variables, the ciphertext or the clear text, we can get back the key. Or if we have the encrypted the ciphertext and the key, we can get back the clear text, the password. So I'll show you with a demonstration using the same bits what we took here. For example, our encoded output that we got from this example is 10110001. Okay, this is our en, our encrypted file. Now if I have the original password with me, and I'll write that password down, which is 1100110101, right? So we can get back our password, or our a portion of our key, because if the password is longer than the key's length, it's going to repeat itself over and over and over again. Okay, so to get back a password, you can see get back a key, we get it as 0 1. This is 10101010. So you can compare the key and the what we got from XORing, and en and p, we get the key back again. Using the same logic of it, if you have an image which we have got it, which is the encrypted file, using the known bits what could be in a png file, I can try to get the portion of the key. Now lucky for us that this key is 8 character long, and the file signature of any png file is going to be 8 character long. Maybe I can even show you that. List of file signatures. Okay, so now every file that we are going to be using in computers, they are having a predefined signature in them. For example, in our case, we have a PNG file. This 8-bit code, the hexadecimal code, is going to hexa signature, basically is going to be the signature, or is going to be something which is going to tell the computer that this is a PNG file. For example, we can even have it in other text formats. We can even go for JPEG, JPG. Okay, this is going to have multiple hexa signatures in it. We can even go for MP4. I guess it's there. So like this, these are the signatures which is going to tell the computer to identify itself as a PNG file, or a MP4 file, or a JPG file. Now going back to our challenge here, let's go to the top. This is 8 character long again, divided into 2 bits. 1 2 3 4, so 5 6 7 8. 9, 10, 11, 12, 13, 16. So they're clubbed into two things, which is going to come back to 8 again. So with the logic again, going with no, having the encrypted file and having a portion of the clear text or a password, we can get back the portion of our key, which was used for encrypting our file. So because luckily both the characters that is being used are 8 characters itself, we might be lucky enough to get the entire key. So let's delete this and let's use an operation of XOR and enter the key. We are hexa signatures of it. Now, if you look down here clearly, we can see the key, which is art, word art, right? Which is encrypted over and over again. Let's copy this. Now, this is going to be our key, which can be used for generating this image back again. I'm going to remove this, enter the key which I found in. It's usually going to be in EF8 format. Okay, now I see this is saying PNG file, right? If it was in hexadecimal or hexa characters, you don't see this because it's trying to convert this into an hexa file, which I don't want in UTF-8. It's basically an encoding algorithm, computers stuff. Now I can render the image right here. I can even download this image and put it as a PNG file and then open it using any file or image editors or image applications. So we get the flag, which is in the format of a PNG. That is MetaCTF known plain text decryption. Right, so this was basically a very simple example of an XOR algorithm on decrypting images and file formats. Hope you learned something and enjoyed it. So, okay then, thank you.